good morning to everyone. Today I am discussing about the importance of geophysical methods. So what is the necessary of in the civil engineering point of view in the geophysical methods? So there is the importance of geophysical methods to know about to that subsurface lithology. So for example, if you seen into that, so we don't want to predict in that what will be exact subsurface area. We don't know about to that. So if you know about that subsurface, definitely, so we dig a borehole in that particular area, so which we want to interested to that. So if you dig the borehole, we have to collect the soil samples. We know about to that what type of subsurface is there in that particular area. So that is the one methodology we are followed to that earlier days. But geophysical methods, we are not able to dig a borehole in that particular area. If you using the simple instrument in those areas, so we getting the information, so without any collection of any soil samples. So for example, if you put into that one geophysical instrument in that area, so when the electrical charges will be passing into those areas, so definitely we can getting to that based on the chargeability conditions. So we getting some information to that what type of lithological structures in the subsurface. So that is the importance of geophysical methods. So basically in the different types of geophysical methods is there. So one is the different types of geophysical methods is there. One is the gravity method, another one is the magnetic method, another one is the electrical resistivity method and seismic method. These are the most of the civil engineering point of view we have to utilize to that. So any geophysical method to understanding of subsurface, so getting the information to that, so our purpose. For example, if you know about, if you find out to that what is the exact place of water zones is there in the subsurface. So we are using to that simple electrical resistivity method. So based on the electrical resistivity method, based on the variation of electrical charge variations, we are able to find out to that what exact place in that what is availability is there. So that is the major importance of geophysical. The importance of geophysical not only for civil engineering point of view, it's also using the major scientific areas in the engineerings, and the same time the using that environmental applications. So these principles always is given to that some basic evidences of subsurface soil conditions. So these are the importance of geophysical methods. So geophysical not only for that, if you seen into that various scientific or engineering and environmental applications also. So these principles always categorize to that Earth subsurface. So they provide to that valuable information of subsurface lithology. It is the major keynote of to that in the geophysical method for understanding of subsurface geology. So these are the applications we are able to able to know about that while using the geophysical methods. So one is the resource explorations. So what is the resource explorations? Resource explorations means, so whether it is able to find out in the subsurface different types of rocks and minerals. So different types of rocks and minerals and different types of water bodies. So different types of oil and gas. So these are the natural resources. So these are the natural resources. So accumulation in that subsurface of in the earth. So these are the natural resources will be identified while using the geophysical methods. So while using GP methods to understanding about to that subsurface. So based on the subsurface, so we are able to find out the rocks and minerals. We are able to find out the rocks and minerals. So we are able to find out that subsurface water bodies. In that water bodies, say whether it is the fresh water body or a saline water body, we are able to find out, discriminate to that by using of GP methods. At the same time, so different types of oil and gases also we are able to find out to that using of geophysical methods. That is about to that resource exploration. And environmental studies. So environmental studies, it means in the various elemental concentrations incorporate into that subsurface. So we are able to find out using the GP method. We are able to find out to that GP method based on the metal concentration to that subsurface. And geological studies. So geological studies, most of the geological studies we are able to find out that identification of rock and minerals and identification of different types of secondary structures. So structures means, so for example, if you find out to that fault and fold, say earth having the dynamic features is there, earth has a dynamic features is there. So if you seen into that one particular area, so if you seen into that one flat area, so we are unable to find out some fractured zones will be developed underlying of rock masses. One fractured zone will be developing of in that underground masses. So we are unable to find out, for example, if you constructed any type of building, definitely the building will be collapsed. So due to faulting. So we are clearly understanding that where exactly faulted zones is there by using of GP methods. By using of GP methods, we are able to find out to that different types of faulted zones and different types of disaster production and mitigation methods. So it may be related to, so most of the civil engineers constructed any type of buildings or any type of roads or any type of dams, and so these are the always is associated with that surface features. So we are unable to know about to that subsurface. The subsurface is given to that same strongness of supporting up to that for any structure. So if you the subsurface will be strong, definitely they are able to fix into that those structures in that surface area. So in that area we are able to find out by using of GP. So that is the one is the seismic method. Seismic method using to that. So we are able to find out to that by variation of seismic waves generations. So we are able to find out to that exact ground surfaces. And water resource management. So water resource management means most of the areas. So for example, in our area will be deltaic area. So we are able to see into that very plenty of water resources to here. So if you go for the upland areas, so they are always going to they are always dependent to that groundwater. So where exactly available of groundwater by using of GP method we are able to find out that. So in the groundwater conditions where is the available and fresh aquifer zones. Aquifer zones we are able to find out by using of GP methods. So these are the importance given to that different aspects. So one is that so resource of explorations, environmental studies, civil engineering purpose, so geological studies purpose, and natural disaster mitigation purpose, and water resource management purpose. For any geophysical experiments, to understanding to give a systematic knowledge into that subsurface geology. If you know about the subsurface geology, we are able to find out to that what type of lithological structures is there. In that lithological structure, where exactly so different types of resources will be available based on the chargeability conditions. So what type of material is there in the subsurface and what type of natural resources will be there, either it is the water, whether it is a fresh water, whether it is a saline water, whether it is the oil, whether it is the gas. So these are the very clearly we understand to that by using of geophysical methods. So this is the importance of geophysical methods. So those applications. So those applications will be given to that vast investigations will be conducted onto that earth surface, earth subsurface or earth. So vast understanding conditions will be identified those areas. So it will be given to that what exactly in the earth subsurface is there. That is we call it as to that shape of our planet. We are able to see into that. So nowadays we are using to that sourcing find out that alternative ways also to that. But in the earth having different types of resource in the subsurface, so we are able to find out to that those subsurface knowledge. Definitely it's give to that another scenario to improve of economic point of to improve to that. So these are the changes we are able to find out. So definitely we give to that new safety and scientific methods. For the example, if you dig a borehole in that particular area, it will be cost of issue very high. For example, as a farmer, they dig a borehole in the particular area, so that is 50 to 100 meters, so they are unable to use in the scientific methods. So they are already done in that 100 feet borehole, so they are cannot getting the any water in that part. So this is a great economic loss. So before digging a borehole, so we are using to that simple instrument, geophysical instrument, getting the information, so what exact place of water availability. So this is given to that more appropriate method using the nowadays, so that is the geophysical methods. So this is the importance of geophysical methods. Now one of the geophysical method is the gravity method. So what is the gravity method we are using for that? So most of the gravity method using for to identification of minerals and rocks and minerals in the subsurface. So for example, if you using that gravity meter, so based on the gravity anomalies, so we are able to find out to that what is the exact the subsurface geology is there. So this is the gravity method we using for the used for the variation of Earth gravitational field. So we know about to that Earth as a gravitational field. In that gravitational field, some gravitational anomaly will be identified to that. So in the gravity method, based on to that using for that density contrast. So for example, by using a gravity meter, so by using the gravity meter in that particular area, so if you fixing that gravity meter, so in that gravity meter, so in the negative anomaly and positive anomaly is there. So the negative anomaly will give a dense material. So why? Because of when the positive anomaly is there, this particular spring will be elaborated to that. I will show you to that. If you see in that instrument, so in that instrument having fixing to that, one is the positive anomaly and negative anomaly. So in the negative anomaly is gives us to that, in that which are the material having the less density material is there, so there is no showing to that less gravity. If the gravity attraction minerals is there, it will be showing on to that positive gravity material. So these are the instrument, so we are able to find out to that gravitational variations. We are drawn into that, we are fixing into that surface areas, the different locations of that part of the environment. So we are able to find out to that. So based on the gravitational density variations, we have to draw to that based on the gravity anomaly frequencies, based on the depth, based on the area. So we are equal gravity anomalies, we will find out to that, we have to correlate it to that. So if you seen into that, whichever the material having maybe in the distance and the lateral variation and the depth of the density contrast, so we are able to find out to that based on the gravitational variation. So this principle working on to the conditions based on to that, what are the subsurface minerals will be there, what are the subsurface geological conditions is there, based on the density contrast, we are able to find out using to that gravity meter. So this is about to that gravity method we kept into that those areas. So based on the variation of spring and the negative anomaly or positive anomaly, so which are the negative anomaly come, the material will be less dense material. So whichever the material will, the spring will be extracted, so those areas will be high density minerals is there. So if you changes in the small changes will be occur, so we will keep on to identify to that different minerals and rocks into that particular area. So this is about the diagram is related to that. So based on the density contrast variations, so we are able to find out to that drawn the linear pattern to that. So what are the applications in the density gravity method using on to that? One is for that identification of mineral exploration. So mineral explorations means, so we are able to find out to that particular area and the gravity minerals. So we are able to find out to that by using of gravity meter. The gravity meter using for that mineral explorations also. And geological mapping. So geological mapping, it means related to find out that various rocks and various type of structures and various types of morphological features. So we are able to find out that using of gravitymeter. And environmental studies. So environmental studies will be most probably in the similar pattern of to the geological mapping. So most of the areas, the conditions of environment or understanding of subsurface lithological, we are able to find out the using of gravitymeter. And tectonical studies means, so at the time of formations having so one single continent, so that's we call it as the Pangea. And after that one superposition is there, so that is the Panthalassa. So lateral tectonical variation in the Panthalassa, the one superposition will be submerged into this particular landforms. So lateral developed in the different continents and different superpositions present day. So in that tectonical studies, based on the some similar changes will be occurring in that particular area. So most probably we have to see into the earthquakes in the Pacific Ocean region, in the Ring of Fire is there. In that area we are frequently seen into the different types of earthquakes. So not only in the particular area, in that some places in India, in the northeast place, in the sensitivized place, because of those areas very high level of faulting zones is there. So in that area we are able to find out to the tectonical studies. So we are closely monitored to that in the particular areas. So we are able to find out to that, so in that maybe in the chances of getting that any earthquakes or any natural disasters. So we are able to find out using of those applications. So in the data interpretation, so data interpretations means, so we are able to draw the diagram, so based on the anomaly variations. So in the spring, the having to that, so based on the gravitymeter having that negative, based on the spring having the positive. So if the positive is there, so they have in the particular area high density minerals is there, high density contrast is there. If the spring is the negative, so that area is related to less density. So in that density contrast variation, we have to plot a diagram to that variation of density contrast. We have to interpret it to that, say which of equal density values in those areas we will be getting that some information based on the using of gravitymeter. So based on the results we have plot a density variation diagram. So based on the diagram we have to predict to that in that areas we are getting to that such type of density minerals. And terrain corrections is related to that measurement of gravitational variations. In that topographical variations we are able to find out to that. So topography means in the elevation changes. For example, some area earth having some different types of morphological features. In the some areas will be terrain features is there. Terrain it means landscape morphology is different. Some areas we getting that flat areas, that we call it as a different deltaic areas. So in that areas we are able to find out to the different variation of density contrast. So we have the clearly understanding of gravitational method. So we are able to find out in the clear way of subsurface lithological. So any gravity method using of based on the density contrast, we are able to find out to that what is the exact subsurface of lithology is there. Then only we are able to predict to that we are getting the some information, and subsurface geology also we can find out that. So this is about gravity method.